Section 3-9 is on derivatives of exponential and logarithmic functions. The objective is given an exponential or logarithmic function, find the derivative function. So we just have one short example here actually to go over. So let's take a look at it. Example 3 there on page 120 says APR, the annual percentage rate, the APR, is the average rate at which money in an account would increase if interest were compounded only once a year. If $10,000 is placed in a savings account that earns interest at a rate of 7% APR compounded continuously, then N of X, the dollar amount in the account after a number of years X, is given by this equation. So let's go ahead and write that down. We have N of X is equal to, it's the $10,000 that we put in initially times 1.07, that's 1 plus our rate, raised to the X power, 1 plus our annual percentage rate, that is. It says show that at time X equals 1 year, the amount of money has actually increased by 7%. And then secondly, it says find the instantaneous rate at which the money is increasing at X equals 0 and at X equals 1. And then finally, they want us to compare that. It says how do these rates compare to the 7% APR? Okay, so we're going to use our calculator to do a number of these calculations, but the first thing they want us to do was to show that it has actually increased by 7% at X equals 1 year. So let's show how much money we start out with and how much money we have in the account after 1 year, and we can compare those two and determine whether or not we've increased by 7%. So at 0, when we plug in 0, of course, we're going to have 10,000 times 1.07 to the 0. Anything to the 0 power, of course, is 1. So this turns out to be just 10,000 times the 1.07 to the 0, or that's just 10,000, which is what we said. We initially had $10,000 in there. After 1 year, if we plug in 1, we get 1.07 to the first power. So 1.07 times 10,000 gives us 10,700. Okay, and both of these are in dollars. It's the amount of money that we actually have in the account. All right, so you can check to see how much your account has grown by, and then you can check to see if it's grown by 7%. And you can do that by taking the difference in these two amounts and then dividing by how much you started with. So, in other words, I'm actually going to calculate N at 1 minus N at 0 and divide that by N at 0. This will tell me the percentage that my account has actually grown by. So that's the 10,700 minus the 10,000 divided by 10,000. And so that's 700 over 10,000. Some zeros will cancel out here in the numerator and denominator. We get 7 over 100, which is the 7%. It's 0.07, or that's 7% if you want to write it as a percentage. Okay, so we've actually grown $700. We've grown by 7% is what we find there. All right, that was the first part of the question. The second part says find the instantaneous rate at which the money is increasing at 0 and at 1. So since we now know from our previous discussion in this section how to take the derivative of this function, let's go ahead and find n prime of x. Now if you look at your function again, it's a constant, the 10,000, times a function, 1.07 to the x. So our rule for the derivative of a constant times a function is it's the constant times the derivative of our function. And the derivative of 1.07 to the x, that's the b to the x rule. And the rule was it's the natural log of the base, natural log of 1.07, times 1.07 to the x, times the same function you started with. So there's our derivative function, and now we can plug in the two values there they wanted us to plug in, was at 0 and at 1. So we'll calculate n prime at 0 and n prime at 1. And I'm going to use the calculator to help with this calculation because with the natural log in there, that's not going to be something we're going to be able to do without the calculator, really. So we've got 10,000. You could put this into y1 and then use that function notation to evaluate these, but I'm just going to put it here in on this home screen here. So it's 10,000 times the natural log of 1.07 times 1.07, and we're going to raise that to the 0 power for 0. Then we get 667.586. 676.586. I think I said that incorrectly there. $676.586. And this is a change in N over a change in time there. So this was in dollars and years. So this is going to be dollars per year for both of these. Okay. Let's go ahead and calculate what we get after 1 year as far as the rate is concerned. So we'll change that to a 1. And you get 723.948. Okay. And so that's how much we are increasing as far as the actual amount in the account is increasing at $723.94 or 95 cents per year at the end of the first year. So it said find the instantaneous rate at which the money is increasing, and how do these rates compare to the 7% and to the 7% APR. So if you look at the percentage here of what we started with, similar to what we did up above there, where we took the amount that our account was increasing by divided by the amount we started with, the $10,000. If I do that same thing here, I can see the actual percentage that my account is growing by. So at n prime of 0, we are actually increasing at $676.50, almost 59 cents, 0.586 over the 10,000. Again, this will tell me the percentage that my account is actually increasing at. So this is actually 0.067. I guess we can put the rest of the decimals on here since I have them right there, but we don't need all of those. So that's 6.76% is what we're seeing there. Okay. And I guess I can round that to 7.66%. So it's slightly less than the 7% APR. And if we check out what's happening at 1, after 1 year, we had, let me write that value down, it was the 723.948 over the 10,000. This will tell us again the percentage that my account is actually increasing by, the rate at which it's increasing divided by, or the actual amount of money it's increasing by divided by how much I started with. So that gives me 0.0723948. Again, I don't need all those decimals since I have them all there. I'll write them down though. So that's 7.239%. So that's slightly more than the 7% APR. Okay. So we see there, to answer their question, how do they compare to the 7%? At the beginning of that first year, it's increasing at a rate slightly less than 7%, but at the end of the year, it's slightly more than 7%. This is why the APR is called the average rate, because of the fact that it's taking into account the rate of change throughout the entire year. And if you average that all out, it turns out to be 7%. All right, that is the end of this section for us.